Hello everyone, welcome to Aptitude Club, and we are here to discuss this interesting summation called very famously after the Indian mathematician Ramanujan summation. Now this looks very interesting and a little intriguing also. Summation of natural numbers till infinity starting with 1 results in minus 1 by 12. Now it's kind of a mathematical paradox, and this has been proven and unproven in a lot of ways in the past. But the point of making this video and explaining this summation is to exhibit you the beauty of maths and how this equation has been derived and how has it been proved and where it is used. Okay, those are the things I'll be taking you through in the next few minutes, and very easy to understand the summation. And let's get started with the video. So to begin with, first we'll start with Grandis Infinite Series. Now, Grandi was a Italian mathematician, and he came up with the sum of this series, Infinite Series. So let us say I'll take a series S1, and S1 is like this: 1 minus 1 plus 1 minus 1 plus 1 minus 1 till infinity. Now, just for a moment, pause the video here and then think what can be the sum of this series. It can be looked upon in two ways. Okay, suppose someone takes S1 like this, 1 minus 1, and they put it in this way, then again 1 and minus 1, and then again 1 and minus 1, and this goes on for infinity. So I can say this will be 0. If I look at it in this way, 1 and minus 1 I'll put together, so every time I'll get 0 with two terms, and the sum can be 0 also. Whereas I can also look at it in this way also, that 1 plus minus 1 plus 1, then again minus 1 plus 1, then minus 1 plus 1, and so on till infinity. So sum can be 1 also. If I just leave the first term and starting from the second term I start making pairs, minus 1 plus 1, minus 1 plus 1, minus 1 plus 1. Okay, so then I'll get the sum as 1. Now if I take the average of these two results, S1 plus S1 is equal to 0 plus 1, which is 1. So you get 2 S1 is equal to 1, or S1 is equal to 1 by 2. This is one way of proving this, that the summation of this series is not 0, not 1, but actually 1 by 2. One way of looking at it. Very simple explanation. There is yet another way of defining this sum. How? Let me write it here again. So S1 is 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1, and so on till infinity. So what I'll do is I'll write 1 minus S1. Okay, I'll subtract the series from 1. So this becomes 1 minus this entire thing. So 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1, and so on. You can do it in this way, or else let me write it in this way. Let's not skip any step. Properly इसको explain करते हैं. 1 minus S1 means I'll do 1 minus S1 bracket में ले लेते हैं, 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1, and so on till infinity. So I get 1 minus S1. This becomes 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1, and so on till infinity, which is again S1. Sorry. So RHS basically looks like S1, isn't it? So 1 minus S1 is equal to S1. So I get S1 is equal to, or 2S1 is equal to 1, which gives me S1 is equal to 1 by 2. This is called as Grandis series, infinite series ka sum S1 is 1 by 2. Why calculate S1? Going forward, we'll go for a second series. Okay, the second series, let me call it as S2, and I'll write it in this way: 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus 8, and so on till infinity. Let this be S2. प्लस माइनस alternate हो रहा है with consecutive natural numbers. So once you write S2, I can again write S2 in this way also. I'll write same S2 just leaving one place. एक स्टेप छोड़ के लिखेंगे तो 2 के नीचे 1 -2 +3 -4 +5 -6 +7 and so on till infinity. And then what you do is you add these two. So you get 2 times S2. It is 1 -2 + 1 is -1, and -3 + 2 is +1, -1 +1 -1 +1 -1 and so on till infinity. So this twice of S2, how much is this thing now? This looks like S1. So I get S2 is basically S1 by 2 or 1 by 2 divided by 2, or you get summation of the second series as 1 by 4. So far we have got two results. Let me summarize it here, that my two results so far are this. I have got S2, which is 1 -2 +3 -4 +5 -6 till infinity. I got this value as -4, and then I got S1, which is 1 -1 +1 -1 +1 -1 and so on till infinity as 1 by 2. These are the two results that we have derived so far. What is it that we are trying to calculate? We are trying to calculate this sum S, which is 1 + 2 + 3 + 4 + 5 till infinity. This is the sum that we want. So what you do is, from this S you subtract S2. How much is S2? S2 is 1 -2 +3 -4 +5 -6 and so on till infinity. So you have to do S minus S2. So this becomes minus, this is plus, this is minus, this is plus, this is minus, this is plus and so on. So I get S minus S2. This 1 gets cancelled out, 2 plus 2 I get 4. Then 3 gets cancelled out, 4 plus 4 I get 8. 5 will get cancelled out, 6 plus 6 you will get 12. Similarly 7 will get cancelled out, 8 plus 8 will get 16. And this goes on till infinity. So S minus S2, what is the value of S2? It is 1 by 4. And here if I take 4 common, I'll get 1 plus 2 plus 3 till infinity. Now this bracket is nothing but S again. So I get S minus 1 by 4 is equal to 4S. So if you solve this, you will get 3S is equal to minus 1 by 4, which gives you S as minus 1 by 12. And that is what we are supposed to calculate. What is S? S is 1 plus 2 plus 3 till infinity. Hence you get 1 plus 2 plus 3 till infinity is minus 1 by 12. Very simple proof. And this equation or summation was given by Ramanujan in 1900s, and it is still useful in string theory and applied in a lot of infinite series, divergent series summations when this fundamentals are used. Okay, it looks quite intriguing that how come if I add all positive integers I'll get a negative number as my sum. But while solving divergent series, we have to come up with a countable infinity. We call it as countable infinity, and then we'll approach the question in this way. So hope this summation gave you an idea of how to think about series and especially infinite series. I'll be taking up more such like questions in each videos upcoming in the channel, and you'll get to know the summation of different types of series. But for now, I hope all of you understood the derivation of this. Grandis series S1, and from there I got to S2, and from S1 and S2 I got to S, which is my actual sum that I want to derive this thing. Minus 1 by 12. Very interesting, and I hope all of you understood this. So S 1 plus 2 plus 3 till infinity, I got it as minus 1 by 12. Ramanujan's summation. So that is it from my end for this video. Hope all of you liked the explanation and understood this. We'll meet again very soon in yet another intriguing question. Till then, keep solving, keep studying, and if you have watched it this far, do subscribe to the Aptitude Club channel for more such interesting videos. Till then, have a nice day, everyone. Thank you. Bye bye.